Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit, and in this series we are discussing the various coolant. So we have defined that coolants are classified into the two categories, dielectric and non-dielectric fluids. Dielectric fluid is an electrically non-conductive liquid that has a high resistance to electrical breakdown even at a high voltages. So the the basic various cells are immersed in a dielectric, and the dielectrics then flows through a heat exchanger to extract the heat. So the dielectric is in direct contact with the cells and bus bars, and hence thermal barriers are minimized. So in the dielectric fluid it is also a direct contact coolant here. So you can see on the screen that here we are having a dielectric and that is immersed into the coolant, and from here you are seeing there is a tube that from here it is flowing and it just exchange the heat to the system. So in this manner it will cool down the system. So this system is cooled down by using the dielectric coolant. So this is not though a simple solution, as in dielectric is just a heat transfer medium and there are lots of parameters to consider. There are like thermal conductivity, like chemical properties, and moreover it's a physical property. So these properties we have to keep in mind. So there are the various pros and cons of this, in which we are having the heat transfer from complete cell surface. Another is the heat transfer from the bus bar. That is the benefits of this type of dielectric cooling. It is having a low cell to cell temperature deltas. It is having a high power output, moreover faster warm up takes place here. What are the cons? Where we are having a high cost of dielectrics we using here. It is a heavier system. Material compatibility tests are also required in this system. More maintenance are required. Cell failure into the dielectric could degrade the properties of the dielectric fluid. Moreover, the structural damage of the pack could release oil into the environment. So the heat transfer from the cell surface directly into the coolant medium is a significant advantage based on the area, and however the dielectric fluids have a low heat capacity and conductivity than the water glycol. So this means that the fluid flow path and the rate are important design parameter to avoid the local static boundary conditions on the surface of the cell. So change in the space between the cell due to the cell swelling causes an imbalance in the flow. So we have to keep in mind that the cell must be there must be a space between the cells. If we increase the space between the cell to eliminate the sensitivity, we end up increasing the overall fluid volume and therefore the mass of the system. Here the dielectric fluids are divided into two parts. First is a single, second is the two-phase dielectric fluids. So two-phase fluid increase the heat transfer by using the latent heat of the evaporation of the liquid to the gas phase transition, and this does increase the complexity of the design. So it work on the single as well as the two-phase dielectrics. So now you see here we are having a single phase immersion cooling. So single phase, the left hand side we have the servers here, and right hand side it's warm coolant output, and right hand side there is a coil which is the cold water output. So and cold coolant input and the warm water output, and that is the that type of the system we use for the single phase immersion cooling. Now single phase coolant never change state. It never boils or freezes and always remains in the liquid form. And moreover, single phase is the same phase, like so its phase will not change, it will not be freeze, it will not be boil, not gaseous form, but it is the same, it will be in the liquid form. And there is a easier to access. Third is does not require a high level of the maintenance. And there is a two phase system. You can see here the two phase system are defined here. There is a warm water output and below we are having a water pump, then we are having a cold water input. So here you are seeing that there are cells, and from here we are using the coolant, and that is used for there is a boiling limit also, that limit will be under the thermal conductivity. So in the two phase cooling, the working fluid boils and does exist in both the liquid as well as the gas phase. At it is boiling, so it will convert into the gas phase. So not the same phase, but it change into the liquid phase to the gas phase also after boiling. So it is complex to the excess, and moreover it requires the more maintenance. So what are the opportunities? So more cooling capabilities allow the battery to be run hotter. So what for that, low internal resistance are required and more power. Reduce the bus bar cross sectional area as that it dissipates through the dielectric fluid. So extend the lifetime with the lower temperature gradient. So moreover, the sensing properties of the dielectric fluid to pre-detect electrical breakdown due to particles or the water ingress. So contain the system without a header tank to remove the service equipments. So what are the example of this? It is a crystal. That crystal designed a cylindrical cell. It is in the form of the cylindrical cell, and so that it can prepare a cooling system. So a crystal designed a cylindrical cell cooling system designed where the main body of the cell is cooled with the dielectric fluid, and the lowest temperature spread of less than 1 degree centigrade on the pack level, which avoid the early single cell aging. So note that the coolant does not flow over either end of the cylindrical cell and hence does not cool the bus bar. You see on the screen here we are having a various cylindrical cells. So and it does form the bus bar, and that is used and it is immersed into the liquid and they are connected with each other. So another is the Lion Smart. Lion Smart develops a high weight batteries and pack with the integrated immersive cooling technology using the 3M Novak fluids, and that is one type of that can be used in the automotive or the aviation productions. So this is also used in the wiring system. So that is used in the lightweight battery packages. You see on the screen, that is the one type of the manufacturing is done here. Now another is the McLaren, that is the P1 GTR original battery and upgraded battery are both dielectrically cooled. So this type of battery uses the dielectric coolants. So McLaren Speedtail has a very small, energy dense and powerful dielectrically cooled battery pack so that it can cool the system. Mercedes AMG HP B80, that is also dielectric fluid to cool the central selection of for this we select the dielectric cooling also for this, and the central section of the cell body it uses that will be cooled by the dielectric fluid. So this pack appears to have a closed system for a dielectric fluid, probably requires to stop it being wrongly topped up or the refilled. Now you see here, this is the one type of, and it is also in the form of the bus. There is a one type of the packages. So it is used for the other is a remac, that is that appears to use the patented dielectric cooling, where it cools the bus bar at each end of the cell before then flowing the fluid over the main cell body. That has been published in the patent, and that cooling patent from the Rimac automobile appears to show that the dielectric cooling system for the Cognigi regra, that dielectric enters the module and flow over both the ends of the cell before returning over the center section of the cell and exiting the module. So here you see at the center of the cell, you are seeing there is a packages at the center of the cell, and that center of the cell is cooled by the coolant, and that is a dielectric coolant required. So here you see that at the center, you see that is a flow from the center to the other part. So there are chambers, there are the bus number that are used for the deliver of the coolant. Now another coolant is the another coolant, dielectric coolant, which is used in the zinc mobility. So test result according to this shows that at 10 degree centigrade delta between the immersion oil and indirect liquid cooling methods used for the cell surface temperature. So that can just cool from 10 degree delta, 20 degree delta on the bus bar temperature. So no fire propagation were detected when during the nail penetration to the single cell, causing it to undergo the thermal runaway. Moreover, immersion coil cooled battery modules test 10% longer the lifetime compared to the conventional indirect liquid cooled module. So these are the basic. Now you see, this is the zinc mobility that has been published in the one of the paper, research paper, that here they are having the cylindrical cell, 21700 cylindrical cell, and the dielectric coolants are put in these cells. So these type of the coolant system are used for the various purposes. Another application areas of these coolants are HV transformer. Dielectric cooling has been used for the HV power transformer for the very long time, and hence this area is good source of the information. Moreover, it is used in the IT data centers, where we are having a lots of systems, and that we are having a lot of server systems, we have the router system, and data centers in the IT sector is also produce the heat when it is working. So for this we also use this type of cooling system. So moving towards the dielectric cooling to the increase the density, reduce the hardware failure, and minimize the water usage to reduce the cost. So that is used in the dielectric coolants. Now another is the non-dielectric coolant. What is this non-dielectric coolant? Non-dielectric liquid coolant are often used for the electronic cooling because of their better thermal properties as compared to the dielectric counterparts. Means they are having a better thermal properties as compared to the dielectric coolants, but they are normally aqueous solution and thus exhibit the high thermal conductivity and high heat capacity as well as relatively low viscosity. So in this category, what type of material, what type of coolant we use, in which we use the water, that another is the ethylene glycerol, glycol, and another is mixture, and that is the ethylene glycol as well as water mixture, which is very popular and widely used as a coolant for many electronic devices. So, some other popular non-dielectric coolant which includes the propylene glycol, that is PG, water, methanol, water, ethanol, NaCl solution, that is the brine solution. Moreover, potassium formate, that is KFO solution, liquid metals like in which we have the gallium, indium, and another is that has been reported and evaluated by the Mohapatra and Lockitts that evaluated that among the various coolant, KFO solution possesses the highest overall efficiency. So, potassium formate is a good coolant agent. So, it is having a high efficiency. Moreover, the several key properties of the various commonly used dielectrics and non-dielectric coolants, the comparison properties of these coolants can help to selecting the right coolant for the particular system. So, in this we have, there are the some common non-coolant, there are some non-dielectric coolant. Water, we all know very well that water is widely used for a coolant due to the high thermal conductivity and availability, and it is often used as a combination with the other additives to improve the performance and prevent the corrosion. Another is the ethylene glycol that often mixed with the water to lower the freezing point. So, there is a one question that why we add the water in the ethylene glycol, just to lower the freezing point and increase the boiling point and making it suitable for a wider range of the temperature. Another is the propylene glycol, that is PG, that is similar to the EG, ethylene glycol, but considered the less toxic, though it can be more viscous and potentially more expensive. So, another is the methanol, that methanol or the ethanol, these also mixed with the water. So, here is a water methanol or the water ethanol, and these mixtures offers a lower freezing point as it is mixed with the water, and the water alone and are sometimes used in the specific application. Another is the sodium chloride, that is the brine solution and used in the certain application, but its electrical conductivity needs to be carefully managed and prevent from the corrosion also. Another is a potassium formate solution. What is this? This is another option that is particularly for the application where a higher boiling point is desired. So, there are some non-dielectric fluids according to its application. Another is the liquid metals. Liquid metals, alloys like Ga, indium, and that can be used for the non-dielectric cooling system, and due to its high thermal conductivity, and they are used very carefully for their potential, for the they are having a potential just to prevent from the corrosion, and their use requires a carefully consideration of their potential for the corrosion and the other issues. So, these type of coolant, these are the non-dielectric coolants are used according to its uses. So, what are the application of the non-dielectric coolants, which are often used in the direct cooling applications where the coolant does not directly contact the electrically components, or in the system where the electrical components are protected by the dielectric barriers. As we have discussed, this is the non-dielectric cooling system according with their parameters, according with temperature, according to with their boiling point, freezing point, and how the thermal conductivity, specific heat, viscosity and density, and these are the basic point which keep into the mind for selecting whenever we select the coolant, not only the dielectric but also the non-dielectric coolant. So, left hand side we are having the non-dielectric coolant along with its various properties. So, these are the various coolants, and we are using it for the various purposes. So, here we have seen that we are having a two type of the coolant, that is dielectric coolant, and we are having a non dielectric coolant, and both are having a different properties, and they are both are having a different usages. Some use in the electronic devices by the direct contact, some used in the electronic devices by the indirect contact. Generally, the non dielectric coolants are used in the form of the indirect cooling system. So, because there is a prevention of the corrosion, moreover there is a prevention of the other activities, but dielectric mostly just in the in contact type of cooling systems, where the cells or the plates are immersed into the coolant, that is a dielectric coolants. So, there are the basic difference between the dielectric coolants and the non-dielectric coolants. Non-dielectric coolants are easily available, and most of the time they are used, but there are some pros and cons in both the systems. In the non-dielectric coolant there is a problem of the corrosion, but in the dielectric there is a less possibility of the corrosion of the system. So, whenever we use as we are seeing that in the non-dielectric coolant we are using the water. So, water just produce oxidation with the system. So, that is why sometimes that non-dielectric coolants are used in the closed circuit, in the closed system, but the dielectric use in the open system. So, and moreover we have discussed that here we are having a various type of the dielectric coolant and non-dielectric coolant, and how we put into the single phase and in the two phase system. Single phase, it is, if it is in the liquid phase then it will be in the liquid phase, but if we talk about the two phase, so two phase it will convert from the single phase to the second phase. Like if we are using a liquid, then if we boil it, then it will convert into the gas, or sometimes it will be just freeze. So, that is very less in the dielectric coolant system, but in the non-dielectric coolant system there is a possibility of more, because it is having a various feature and various point. So, the coolant we are using in any electronic devices according to its requirement and according to its purpose. So, in this lecture we have discussed the various coolant, and previously we have discussed the electronic cooling. Now, we will further in the next lecture we will discuss the various electronic component that will be used in the electronic circuit. And we can see that this type of cooling where we are having a cell and we are having a various different type. You can see in this figure that we are having a 21700 cylindrical cell that are in contact with each other, that will form a sheet like structure, and that is used for the coolant, as a coolant. And all these 2177 cylindrical cell having a dielectric coolant in it, and that that system is used to cool the another electronic devices. So these type of formation are used according to the requirement. How bigger system, how much high power system we are having, and how will cool. Similarly, as you have seen in your inverter batteries, that we are using, there we are using the water. Distilled water we use just cool down the batteries in the inverters. So there are the various coolant agent just to just put into the various devices. So as the water is put into the inverter batteries, so it will cool down the system and it will work for a longer time. So for increase the performance of any electronic devices, just to prevent from the overheating, coolants are basically used. So coolant also play an important role in the electronic circuit. So with these words, just I wind up, and we discuss another electronic device in the next lecture. Thank you very much.